So these are going to be the notes for section 5.1, which is all about how to find the derivative of the natural log function. So basically, there's a rule to know in order to find the derivative of natural log. It simply is going to be 1 over x. There's not a formula to develop that. It's just a rule that you have to know. Now, the chain rule version would be what if it's the natural log of something more than just x? What if it's the natural log of 2x, the natural log of x squared, or the natural log of some function of x? Okay, so we're going to say u is some function of x. So if I want to take the derivative, think about the chain rule. It's still going to be 1 over u, right? Derivative of natural log of x is 1 over x, so the derivative of natural log of u is going to be 1 over u. But the chain rule would then say, well, times the derivative of the inside. Well, the inside is u. So if the derivative of u is u prime, then basically we're saying the whole thing comes out to be u prime over u. So in other words, whatever you're taking the natural log of, the derivative is going to be the derivative of the inside over the whole thing. So for example, if you look at if y equals the natural log of 2x, so this is the function of x that we're talking about. So the derivative would be, the derivative of 2x is 2 over itself, so over 2x. So that's my u prime over u. And if you simplify it, it comes out to just be 1 over x. Now, coincidence that it turned out to be the same derivative that we have up there. So in this case, the entire u is everything inside the parenthesis. So the derivative would be u prime, 2x plus 2, over u is that entire thing, so over x squared plus 2x. Nothing I can do to simplify that. That's my derivative, u prime over u. Something to keep in mind is sometimes it's useful to use log properties before differentiating. Okay, according to what we set up above, if all of this is the u, now don't write, I just want to show you, if all of this is the u, when I go to do the derivative and do u prime over u, in order to do the u prime, I would have to do the derivative of this entire square root. So again, don't write yet, just watch. If I'm saying I want to find the derivative of that, so in other words, u is x over x plus 3 to the 1/2. So just to do u prime, I would have to think chain rule, 1/2 times all of this, right, to the negative 1/2. But then the derivative of the inside would be the quotient rule, right? Derivative of the top times the bottom minus the top, derivative of the bottom, all over the denominator squared. And that's just the u prime, okay? We don't want to have to go through all that, okay? So this is why I told you don't write. Okay, so as I was saying, I don't want you to write all that out. If we do a log property before we start doing the derivative, it's going to be a lot easier. So I'm not doing the derivative yet. I'm just thinking through how I could simplify this. Remember the log properties say you can bring the exponent down in front. So I'm going to bring down the 1/2, right? That's the square root. And then I still have the log of this fraction. So I just did that third log property. But let's say I go further and I leave the 1/2 out in front. And then because this is a fraction, I could do the log of the top minus the log of the bottom. So basically I've just expanded this, right? So that now what I started with is actually the same as all of this, right? Now, if I do the derivative, look at what's going to happen. I'll leave the 1/2 in front, but then I can do the derivative of each of these separately. Well, the derivative of natural log of x is just 1 over x, bring down the minus. And the derivative of all of this, now think about it, this is my u, would be a u prime over u. So wouldn't that be 1 over x plus 3? So instead of having to do that big ugly u prime, when I stretched it out into individual logs, the derivative of each one was much easier. Okay? Now there's one other thing that could happen. Notice I'm asked to find the derivative of this big ugly fraction. It's not a log, so it's not like a u prime over u. If there were a log right there in front, I could do what I did up above, where I could stretch this out into a whole bunch of different logarithms. So why don't we do that? I mean, I can't just put a log on one side, but logarithmic differentiation says, well, what if you were to take the log of both sides? Okay, if I did that, then I would have on the left the log of y equals, now yes, it's the log of the whole thing, but let's start stretching it out. Log of x plus log of square root of x plus 2 minus log of x minus 3 to the fourth. Okay, now I could go ahead and do a derivative right now, but why don't I clean this up even more? Why don't I bring the 1/2 down in front? Why don't I bring the 4 down in front? So what I have is log of y equals log of x plus 1/2 log of x plus 2 minus 4 log of x minus 3. Okay, now let's take the derivative of both sides. So the derivative of the natural log of y, well, it's 1 over y, but then think chain rule times the derivative of y. So basically it's going to be y prime over y, just like saying the derivative of log of u is u prime over u, equals derivative of natural log of x, 1 over x, plus, leave the 1/2, the derivative here, think u prime over u, so it's going to be 1 over x plus 2, minus, leave the 4, think u prime over u, so 1 over x minus 3. Okay, now what was I originally supposed to do? I'm going to go up here and just kind of erase this log so you can kind of see what the original was. We were trying to find the derivative of this. In other words, we were trying to find y prime. Well, come down here. If I want to find y prime, couldn't I just multiply by y and then I'd have y prime? So y prime So I'm going to multiply by y. So y prime is basically y times all of that, right? 1 over x. And for this, I'm just going to write this as 1 over 2 times x plus 2 minus 4 over x minus 3. Now, this is correct, right? And I could call this done, but I am going to mention this. A lot of times, if the original starts out completely in terms of x, then the answer choices, once you want them to be all in terms of x. So in place of y, if I wanted to, I could put in this big ugly mess. So again, I'm just saying if it's a multiple choice question, it's very likely that they won't have the y there, but instead they'll have x times the square root of x plus 2 all over x minus 3 to the fourth, and then times all the rest of this, right? 1 over x plus 1 over 2 times x plus 2. Again, I know it's big and ugly, but it doesn't matter. I've solved for y prime. So it might be written either of those ways. Okay, I just want to point out the homework. Again, it's what's listed on your calendar that's on Canvas, and you don't have a hard copy yet, so you're probably going to want to go ahead and notice the homework right here, but you should have a printed copy of all this put together like I've been doing for you, and it looks something like this. So you can tell what I did. The entire homework assignment is listed up here, and then I've got the problems listed, and like I did before, I've got, you know, your 6 blanks. Please do like I've asked you to do before, where you actually write down the problem and then the original function, right? F of x equals natural log of 3x, and then you can go in and say, oh, okay, f prime of x equals, and do your math. Okay, so this should take you 47 through 52, and you'll notice I've got boxes for each part. One thing I'll mention is, don't forget, when you get down, really I would say 53, 55, and especially down into these, use that property that I showed you where first stretch it out using multiple logarithms before you start taking the derivative. So for example, when you get to 57, right? Instead of f, I'm just going to say y equals. Maybe before you even write down the problem, you don't call it natural log of a fraction, but you just already call it natural log of x minus natural log of x squared plus 1. So it is okay to go straight to that step, and then you can do your derivative. The other thing I'll mention is when you get over to these problems that have the absolute value, that does not affect, I know normally we say we don't do the derivative of absolute value, but they just, it's kind of like an implied parenthesis right there. It's just that a lot of times you'll see an absolute value inside of a logarithm because you can't take the log of a negative number. But again, don't let that affect anything you're doing. Just kind of think of it as a parenthesis. You can kind of think of this as a parenthesis. Okay, so basically just make sure you kind of read the directions, and when you get down to like number 87, it says use implicit. Well, you know what implicit means, right? So maybe I'll just kind of help you get started on number 87. If this is my original equation, when I jump in and start doing the derivative, they say to find the equation of the tangent line. But if I start doing the derivative, well, the derivative of x is 1, the derivative of y is y prime minus 1, that derivative is nothing, equals, now over here, when I do the derivative of natural log, think u prime over u, so it's going to be 2x plus 2y y prime all over itself, so over x squared plus y squared. So that's my derivative. The only other thing I'll mention is if I want the equation of the tangent line at this point, I don't really have to solve for y prime, because once I solve for y prime, I'm going to plug in my ordered pair 1, 0 anyway. So why don't we go straight to plugging in the 1, 0, and then we'll solve for y prime. So in other words, I'm going to have 1 plus y prime equals 2 times 1 plus, if I plug in a 0 for y, won't that be a 0? All over 1 squared plus 0. So in other words, y prime is simply what? 2 minus 1 is 1. And now you can finish and write the equation of your tangent line, right? Y minus 0 equals, and then your slope, we said right here is 1, and then x minus 1. Okay, not only did I get you started, but I kind of did the whole problem. So there's number 87. So you can use that same idea of implicit, and you guys can then do number 88. Okay? Good luck with that homework. Again, sorry I can't be there, and I will see you guys on Wednesday.